Welcome to the Toxicological Studies module. And toxicology is one of the most dangerous thing in the process industries, apart from fire and explosion. Now, it is not only poses the immediate danger, but sometimes its effects you may observe in due course of time or even the later part of your life. So, in this particular module, we will deal with what is toxicity, what is toxin, and how we can go ahead with the toxicological studies. What are the different routes through which any toxicant can enter your biological system? What are the exposure symptoms, etc. Now, this, as per the United Nations Organization report published in year 2016-17, almost 8.3% of all deaths are attributed to the environmental exposure. These exposures are attributed to the selected chemicals each year. And remember, don't forget the Bhopal gas tragedy. It is because of one of the most toxic substance, methyl isocyanate. Now, major contributors to this toxicological aspect are indoor smoke from solid fuel used, outdoor air pollution, and second-hand smoke followed by the occupational particulates, chemicals involve the acute poisoning, and pesticides involved in self-poisoning. Now remember, whenever we talk about the pesticides, they are intermediate during the production and even raw material causes a severe problem. Now question arises, what is toxicology? This involves all aspects of adverse effect with the chemicals on living system. Those effects which are damaging to either the survival or normal function of individual. So this is toxicology. So whenever we study the toxicology, then question arises, what is toxicity? So the term toxicity is used to describe the nature of adverse effect produced and the conditions necessary for their production. So remember, we will consider the process as well as end use. Now, before toxicity can develop, a substance must come into contact with a body surface such as skin, eye, mucosa, or any other alimentary or respiratory tract. So in this particular chapter, we are going to deal with all these aspects. Now, before we go ahead, let us understand that what is toxic, toxicant, and toxin. Now, toxic substance, they are available in two forms. One is the nature-oriented and second is the man-made toxicants. So toxic, this term relates the poisonous or deadly effect on the body. Now, toxicant, this term toxicant refers to the toxic substance that are produced by or are by a byproduct of human-made activities. Now, toxin terms, the term toxin refers to the toxic substance that are produced naturally. So, you can clear-cut demarcate the three different aspects of toxicity. Now, if we consider the history of toxicity or toxicological studies, in between 50 to 400 AD, Roman used to poison for execution and assassination of their enemies. The philosopher Socrates was executed using the hemlock for teaching radical ideas to youth. Avicenna, between 980 to 1036 AD, Islamic authority on poison and antidotes. 1200 AD, the Spanish Rabbi Maimonides write first aid book for poison and their antidotes, because whenever we talk about the poison, whenever we talk about the toxicity, whenever we talk about the toxin, then definitely you must think about the remedial measures. Now, Swiss physician Paracelsus in 1493 to 1541 credited with being the father of modern toxicology, because it's a science rather than the poison, it's a science. So all substances are poison, it's his verdict. There is none which is not poison. The right dose differentiate a poison from a remedy. Even water may become fatal. If you take the excess dose of water, definitely it may become fatal, and sometimes it may create a further problem. So that's why all substances are poison, and you have to find out that what is the actual dose which is required for the body system. And if you take the excess dose, then definitely it may create a problem to your body structure as well as environment. I would like to quote an individual view by S.J. Gilbert, The sensitivity of the individual differentiates a poison from a remedy. The fundamental principle of toxicology is the individual's response to a dose. Now remember, whenever we talk about the individual's response, this covers the age, atmospheric condition, sex, etc. Because sometimes if you are young, then you may overcome any kind of toxic exposure. But if you are a kid or if you are a bit older, then definitely you may be overexposed to those kind of dose. And if you go to the doctor, then definitely based on these parameters, they decide the actual dose of any medicine. Now there is a hairline difference between the toxicity and hazard. The toxicity, the ability of a substance to have an adverse effect on the health or well-being of human. The toxicity of a chemical depends on the degree of exposure and absorption. However, the hazard is the probability, hazard/risk is the probability that a concentration will occur at the site in the body. So you need to find out that whenever you got an exposure with the toxic substance, what is the route and at which point of time and at what point of time it is going to affect your body, and what is the target organ which is being affected. So in this particular chapter, in this particular module, we will discuss all these things. The two chemicals can possess the same degree of toxicity but present in different degrees of hazard. It also attributes to several other parameters like your age, weight, physical conditions, etc. The best example is just odorless and non-irritating versus pungent odor. Remember, nature gave you a beautiful things to determine that which one is correct and which one is not correct. So chemical with the warning properties may present the lesser degree of hazard. Now when we go ahead with the systematic study of toxicology, we must know that how these toxicants can enter into the biological system, means your human body or animal body, etc., or to the environment. Then second question must be asked that how these toxicants can affect the organism. Means whenever you are under the contamination of those toxicants, then how these can affect your body system. Now once these two questions are answered, then you must answer the things that how toxicants can be eliminated from your body system or they can leave from your body system. Now all substances, remember again, all substances are toxic if taken in the wrong quantities. So you must know that what is the dose and what is the actual response for that particular dose. So based on this particular aspect, the right dose differentiates a poison and a remedy. It is just like that whenever we got the vaccination, then a limited quantity or required quantity of that particular virus being injected into our body system. So the harmless substance such as water even become the fatal if delivered to the biological organ in a large enough doses, which is not required to your body system. So the fundamental principle of toxicology is there are no harmless substance, only the harmless ways of using the substance. Now based on all these discussion, the people have predicted the most advanced definition for the toxicology. Now toxicology is more adequately defined as the qualitative and quantitative study of adverse effect of toxicant on biological system. So a toxicant can be a chemical or a physical agent including dust, fiber, noise, radiation, etc. A good example of physical agent is the asbestos fiber, a known cause of lung damage and cancer. So government is now thinking to ban all kind of asbestos fiber sheet. Previously it is used as asbestos sheet for roofing or paneling. Now toxic hazard is the likelihood or damage to the biological system based on exposure due to the transport and other physical factor of uses. The toxic hazard of a substance can be reduced by the application of appropriate industrial hygiene technique. So you must create a barrier between yourself and exposure of toxic substance. But the toxicity of a particular substance cannot be changed under any circumstances. So you cannot change the toxicity of methyl isocyanate. You cannot change the toxicity of arsenic. The only thing is that you must know that what is the barrier and what is the threshold limit for the intake for MIC to intake into the body system. Now there are basically 4 routes of exposure for any toxic entry into a biological system. One is inhalation, ingestion, skin contact, and injection. Now these are the 4 prominent routes through which anything can enter in your body system. Now before we go into the detail that how injection, how inhalation creates a problem, we must know several other factors like acute, that is the effect of exposure, the acute, a one-time event, that is the rapid absorption of a material, and sometimes it may cross the threshold limit values. The exposure, sudden and severe, the critical period for death or survival. Similarly, the chronic, that is a small doses versus over a long time. Sometimes if you are working in a workplace and where the small quantity of toxic substance being released, then you may get a very small doses. Those doses of toxicant may accumulated within your body system, and the effect may appear after a long time. So sometimes suppose you are working for a year or 2 and you are continuously being exposed to that particular toxicant, that may create a chronic problem. So it all depends on the rate of intake, the rate of elimination. It is both things are altogether substitute to each other. The material remain in the tissue injures, like if the material remain in the tissue, that may get deposited into the fatty tissues, and when you become progressive and you are become older, then all those fatty tissues may decomposed, and the effect of that particular component or toxic substance may be prominent. Now there are various type of toxic effects like mortality, pathological changes, sometimes the growth rate changes, physiological injury, the biochemical change, behavioral effect, sometimes the reproductive system may get damaged, and there are mutagenic changes. So you must know that what kind of effect is going to take place within your body system by the exposure of any toxic substance. Now sometimes these toxicity or toxic effect are governed by the target organ. So you must know, because sometimes if you inhale something, first it goes to your upper or lower respiratory tract, and then it may go into your lungs. And if you sometimes if you take or if you things or any toxic substance through the dermal absorption, then the target organ may be little bit different. So you must know that which of the organ is going to be affected by any toxic substance which you are going to take. Now these are the things which are important in this particular thing, that irritant, sometimes because suppose if you are exposed to the chlorine environment, then first prima facie you may experience the irritation. Then anesthetic, the hepatotoxic, nephrotoxic, neurotoxic, and sometimes pulmonary. So you must identify the target organ. Now target organ, that is the systematic toxin, is one that affects the entire body or many organs rather than a specific site, like potassium cyanide, toxic to every cell and organ in the body by interfering with the cell's ability to utilize oxygen. The same happened in the Bhopal gas tragedy. The toxin may also affect only to specific tissues or organs. They are called the target organ or the target tissues, like benzene, toxic to blood forming tissues, lead, toxic to CNS, kidney, hematopoietic systems. So you must know that which kind of toxin and which kind of toxic substance is there. The adverse effect occur at the level of molecular cell. The molecularly chemical can interact with the proteins, lipid, DNA. Cellularly chemicals, they can be affected by interfere with the receptor ligand bindings, interfere with the membrane function, interfere with the cellular energy production, bind to the biomolecules. Remember, all 4 factors, they play a very vital role when you study the toxicological effect for the later part of life. Now there are various factors influencing the intensity of toxic action. Usually they depend on route of entry. If it is being inhaled by your nose, then definitely at what part is going to affect. Then the rate of exposure, sometimes acute, sometimes chronic, sometimes the concentration of toxic is on the higher side, then you may get exposed more spontaneously. Then age of your body system. Suppose if I am young, my physique is good, then there is a prominent production of different fatty tissues within my body system. Then I may be in a position to retaliate all those toxic exposure. So it all depends on age of host. And suppose a person is old, then definitely because of lesser number of excretion routes, he or she may be get exposed on a dangerous level. Then prior exposure, sometimes you are acclimatized to the system and toxic environment, then definitely all those exposure may play a vital role for the multiple exposures. Then environment, suppose I am working in a humid environment and most of the toxicants, they are hygroscopic in nature. So they may get deposited in your body system, or they may enter into your body system through the skin or inhalation or sometimes ingestion. Again, the host factor, that is your human body, that is gender, male or female, genetics, what is your pedigree, etc. And there are several other factors which we are going to discuss in due course of time. Now, first question arises that how toxicant can enter into biological system. First is inhalation through mouth, nose to lung, and then into the bloodstream. Ingestion via mouth to stomach. Suppose by mistake you have taken the benzene. Benzene is available in both liquid and vapor phase. So by any chance you take the liquid benzene and you take through your mouth, then it may become the part and parcel of your bloodstream. Injection with the help of some certain cuts, puncture into the skin, and sometimes people may deliberately inject certain poisonous substances into your body system, and sometimes by mistake any poisonous system may enter through your medicine or any other injection route. So sometimes cut and your blood vessels are exposed to the atmosphere, and if you are working in a toxic vapor environment and those toxic vapor may get in contact with the bloodstream, so it may become the part and parcel of your body system. Dermal absorption through skin into the blood. Sometimes there are certain components because the dermal skin plays a very vital role in absorption, and because of their pores, because of the hair follicles, etc. So through dermal absorption into the bloodstream, they involve the membrane transport, and this is the greatest threat to the industry. So out of 4 routes, the inhalation and dermal absorption routes are the most significant to the industrial facilities, because whenever you encounter to any kind of cuts, puncture in the skin, definitely your first attention is towards to take the first aid. So by your attempt is to minimize the exposure of those cuts to the atmosphere. So dermal, because your skin, sometimes your skin is exposed to the environment, and inhalation because you cannot avoid this thing because you have to breathe. So that's why out of 4 routes, the inhalation and dermal routes are most significant route of the entry. Now, for higher order organism, the path of chemical agent through the body is well defined, because either if you take through dermal absorption or if you take the inhalation, because it will go through upper respiratory tract, then the lower respiratory tract, and then it will become the lungs, it will become the part and parcel of the lungs, and in the lungs with the bronchi and alveoli, it may become the part and parcel of your bloodstream, and through blood circulation it can go up to anywhere. So after the toxicant enter into the organism, it moves into the bloodstream and eventually eliminated, or it's transported to the target organ. The beautiful thing given by the nature is that whenever your body is contaminated to any foreign chemical, then first of all body tries to retaliate all those things by the various symptoms. So you need to identify those symptoms first, and simultaneously body reacts in an adverse manner to overcome the effect of those particular toxicant. So you must utilize that capability. Now if it is not, then you have to take certain external things to overcome the effect of those toxicants. So the damage is exerted at the target organ if you fail any kind of, or by any chance you are unable to remove all the toxic effect into the body system, then the damage is exerted at the target organ. Inhalation is the easiest to quantify by the direct measurement of airborne concentration. The usual exposure is by vapor, but small solid and liquid particles can also contribute. Sometimes mist, sometimes a small solid particle, they are supported by the mist, etc. They may create a problem. Injection, inhalation and dermal absorption generally result in the toxicant entry into the blood stream. They are usually unaltered. Now in this particular table, we can summarize that there are 4 different entry route. Ingestion, the entry organ is mouth or stomach. You can control this entry by the enforcement of rules on eating, drinking and smoking. Inhalation, it is again from the mouth or nose. You may adopt the method of control in terms of ventilation, respirator, hoods and other personal protection equipment so that the concentration of those toxicants may below the lower level. Injection usually happens in the cuts in skin or through deliberation. You must have a proper protective clothing. Dermal absorption, again it may happen or entry through the skin. You must have a proper protective clothing. So these 4 things are the rule of thumb, and whenever you study the toxicological study, you must know these 4 rule of thumb. Now entry routes for toxicant and method for control deals with the toxicant that enter by the injection and dermal absorption are different to measure and quantify. Some toxicants are absorbed very rapidly through skin based on their molecular structure, based on their concentration to the atmosphere. The expected blood level concentration as a function of time and route of entry. The blood level concentration is a function of a wide range of parameter. So large variation in this behavior are expected. Again, because there are n number of parameters, those who govern this particular aspect. So as an engineer, you must identify that what are those parameters, and at least if you are unable to find out all those parameters, you must enlist 4 or 5 different major parameters. The first prominent route of toxicant entry into the biological system is gastrointestinal tract. The gastrointestinal tract, apart from the skin and other respiratory system, plays a significant role in the various route of entry. The GI tract, as depicted in this particular figure, plays the most significant role in toxicant entry entering the body through ingestion. Food, drink is the usual mechanism of exposure. Airborne particles, either solid or in a liquid form, can also lodge into the mucus and the upper respiratory tract and be swallowed. The rate and selectivity of absorption to the GI tract are highly dependent on many conditions, that what kind of chemical and its molecular weight, because the heavier the molecular weight, the entry may be a little bit different compared to the lighter molecular weight component. What is the molecular size and the shape, like benzene is having the cyclic molecule, then it may create other problems rather than the linear molecules. What is the acidity and the basicity of the component? What is the chances to attack by the intestinal flora? Because I told you that your body system is designed in such a way that it retaliates to the foreign body, and suppose you are encountered with a toxic substance, so initially your intestinal flora and flora attack to that particular toxic substance. The rate of movement of that particular component to the GI tract, that is again based on this parameter and molecular size and shape. Now next aspects, when this toxic substance enters to your GI tract, the next concept is how it distributed to your body system. So blood carries, this is usually they are carried out by the blood stream. So blood carries the agent to and from its site of action, storage depot, sometimes the fatty tissues, bone marrows, etc., organs of transformation and organs of elimination. Now rate of distribution depends upon the blood flow, characteristics of toxicant, affinity for the tissues and partition coefficients. And distribution may change over the time. Again, there are several factors govern this particular aspect. That is, what is the molecular size, molecular weight, age of the host, etc. The next route of entry is your skin. Skin plays an important role in both the dermal absorption and injection route of entry. Now, injection include both entry of absorption through cut and the mechanical injection with the hypodermic needles. So, usually sometimes either in the medicinal way or sometimes deliberately, this type of effect plays a vital role. Now, this is the schematic representation of a human skin. Now, stratum corneum is at the top of the 5 layer, making the epidermis, usually composed of keratinized dead cell glued by the lipids. Now, these are the keratinized cells glued by the lipids. So, lipids are fatty tissues. So, whenever you are growing up or you are young, those fatty tissues may get deposited over the period of time. And if after the aging, these fatty tissues may get decomposed. So, it is quite evident that when you become older and older, the wrinkles they form because of the decomposition of those fatty tissues. So, it is shed off and replace these stratum corneum, it is shed off and replaced every 2 weeks. So, depending on the part of the body, its thickness varies from 0.05 mm to 1.5 mm. The most thickest part is your palm. The respiratory system. The respiratory system plays a significant role in toxicant entry into the body through inhalation. You can avoid, you can cover up your all skin, but you cannot avoid the inhalation because you cannot avoid breathing. The main function of respiratory system is to exchange oxygen and carbon dioxide between the blood and inhaled air. So, these are the main sacs or alveoli or bronchi through which the carbon dioxide and oxygen they are exchanged from the blood stream. So, by any means if they get blocked, then the available surface area for this carbon dioxide and oxygen exchange is diminished and you may experience a breathing problem. And sometimes there are so many chemicals, those who destroyed the active sites available at this port. And sometimes certain solid particles, those who are having the low size or in the micron size, they may get deposited in these alveoli by blocking the active surface area. The respiratory system is divided into 2 areas, the upper and the lower respiratory system. The upper respiratory system is composed of nose, sinus, mouth, pharynx, larynx, that is the voice box, and the trachea or windpipe. So, you can see, I do not know how much visible is this figure, but you can see all these things in this particular figure. The lower respiratory system is composed of the lungs and the smaller structures like bronchi and alveoli, which I showed in the previous figures. The bronchi tubes usually carry the fresh air from trachea through a series of branching tubes to the alveoli. These alveoli are small blind air sacs where the gas exchange with the blood stream. The upper and lower respiratory tracts respond differently to the presence of toxicants. Now remember, this is a key factor when we are discussing, because we cannot overlook the importance of inhalation. So, you must know that which chemical affects which respiratory tract. The upper respiratory tract is affected mostly by the toxicants which are water soluble. Remember, your body is having sufficient quantity of water. These materials either react or dissolve in the mucus to form acid and bases. The toxicant in the lower respiratory tract affect the alveoli by physically blocking the transfer of gases as with the insoluble dust, or reacting with this wall of the alveoli to produce the corrosive or toxic substances. Remember, phosgene, for example, that reacts with the water on the alveoli wall to produce HCl and carbon monoxide, and both the things are dangerous. Like suppose in case if you are in presence of phosgene gas, so and by any means you inhale this phosgene gas, so it may react with the water present in your body system or in your lungs or in a lower respiratory tract to produce the HCl and carbon monoxide. Carbon monoxide is very reactive to your bloodstream, and HCl is having the corrosive property. So it may destroy the inner wall of either alveoli or bronchi, so the blood vessel may get exposed. So they can be more reactive towards the carbon monoxide, and moreover the available sites or the available surface area of for oxygen carbon dioxide exchange is diminishes. So be particular. So this is the effect of one of the effect of any toxic gas. Now as far as the toxic effects are concerned, it depends. Another parameter is that duration of exposure. Usually in engineering term we talk about three terms which are used to describe the duration of any dose or exposure: acute, chronic, subchronic. In the subsequent parts we will study all these things under these three heads. Now acute exposure, application of a single or a short term, generally less than a day dosing by a particular chemical, or sometimes spontaneous exposure. Now if toxic symptoms are expressed, they are referred as symptoms of acute toxicity. Now chronic exposure, the expression of toxic symptoms only after repeated exposure to a chemical in doses regularly applied to the organ for a long time greater than half of its life expectancy. So sometimes if you are working in say ammonia environment, so gradually you may get exposed to those environment, and sometimes because of our nature of body we may get acclimatized and we cannot experience the adverse effect of ammonia, and sometimes our body is acclimatized to give the prima facie symptom. Like suppose first hand, if you exposed to the chlorine environment, you may experience the irritation, you may experience the skin dryness, etc. But if you are continuously working in that particular environment, your body may get tuned in such an environment, so you may not experience. Only thing is you experience if there is any change in the chlorine concentration, then you may experience that something going wrong. So this may be a chance of a chronic exposure. Now if toxic symptoms are expressed, they are referred to as the symptom of chronic toxicity. Now usually in this particular table we will discuss that over time the amount of chemical in the body can build up, it can redistribute, or it can overwhelm repair and removal mechanism, because based on the duration they may become the part and parcel of your bloodstream, and they may get deposited in the various body parts of your human body. Now there are four effects. Acute, usually the time domain is less than 24 hours, and sometimes it is attributed to one exposure. The subacute, the new term, usually the time of exposure is 1 month, and sometimes you may get the repeated doses. Repeated doses, sometimes every dose is not having the same concentration. Sometimes it is on the higher side, sometimes it is on the lower side. Subchronic, usually 1 to 3 months, repeated doses. And the chronic one, it is greater than 3 months. So suppose you are working in an industry and the workplace is having a small dose, a small amount of toxic release. It may club under the head of chronic, and you may experience the repeated doses, maybe the stagnant doses, maybe the fluctuating doses. So this is the exposure pattern. So in this particular module, we have discussed about the different aspect of toxicity, the different definition of toxic substance, toxicity, toxin, etc. Then different routes of entry through which any toxicant can become the part and parcel of your body system. And what are the different qualitative analysis through which we can analyze the exposure of toxic substance. Thank you.